Right, so pretty much this video shows you how to install or wall mount your soap and shampoo dispenser. A dispenser primarily eliminates the need for messy plastic bottles and helps to make even the smallest of bathrooms feel more like a luxury spa. The wall mounting of this dispenser would be beside the wash basin. This is not an electrical component, but say perchance you were trying to drill through a tile. You would need a center punch or a nail to indent the tile, but prior to drilling the tile, you would need to protect the tile with a masking tape to prevent splintering and to prevent the drill bit from moving off of its center when drilling through the tile and through the wall. And if you're trying to fit an electrical component, you should have some basic knowledge or awareness of the Ingress Protection codes for the zones where you're trying to install your electrical component, as well as some basic idea of your bathroom layout, because you don't want to be drilling through pipes or electrical wiring. You want to be actually getting them studs. So at least some basic knowledge, or fundamental knowledge of what your plausible or probable bathroom layout is will suffice. When a plumbing system layout plan is being developed as shown, depending on your setup, you can choose from several venting types, but each option could present problems or complications. And that's why it's important that before finalizing a plan like this, you have the venting scheme approved by a local plumbing inspector. So you can pretty much see where the true vent is located. It's a vertical pipe attached to a drain line that travels through the roof with no water running through it. But bear in mind that many fixtures are not so conveniently located. If it's not conveniently located, other solutions must be found, okay? Whereas the revent pipe that you see there is also called an auxiliary vent. It attaches to the drain line near the fixture and runs up and over to the main vent. In your bathroom, you may also find that it's been attached directly behind the fixture or to the horizontal drain line. Depending on your bathroom layout setup, you might have two fixtures, on the opposite sides of your wall. They usually tie into the stack with a sanitary cross, and that's what we've got exemplified as shown. And as a venting alternative, what happens when the window framing in your bathroom prevents the installation of a vent line? You might have an air admittance valve installed instead. So basically, when waste drains, it opens to let air in, then gravity closes it to keep sewer gases from escaping back into the bathroom. Drain waste vent pipes carry waste and water smoothly out of the house without gurgles or fumes. This essentially requires an air passageway behind the water. So basically you've got vent pipes, extending from the drain pipes up through the roof to provide that passage while also carrying odor out of the house. The centerpiece of a drain waste vent system is the main stack, usually a pipe 3 or 4 inches in diameter that runs straight up through the roof. The secondary stack that you see, perhaps 2 or 3 inches in diameter, serves as a branch of the system. Then branch drain pipes of smaller diameter, typically 1.5 or 2 inches, carry water from specific fixtures to a stack. So pretty much, venting is necessary because it allows air to enter behind the flowing liquid, producing a quick gluck-free flow. And so basically, the critical distance or how far the fixture can be from the vent pipe is determined by 3 factors: the size of the pipe that the codes require, the type of fixture you want to install, and the number of fixtures that are already wet vented on the same line. And that's why it's important to use a pipe and cable detector, to ensure that all areas are free of hidden pipes and cables, and also use a stud detector to locate the position of the studs. As we've pretty much discussed what the sizes of certain pipes behind the wall could be. So say for instance if I were installing an electronic device as opposed to installing the dispenser, I would be taking the bathroom zones into consideration. Bathroom zones are areas where electrical equipment must offer a certain degree of protection against water. It refers to the amount of water likely to be present, so the lower the zone number, the higher the ingress protection rating needs to be, or you can call it the IP rating. And vice versa, the higher the IP number, the better the protection. The first IP number ranges from 0 to 6. This refers to the level of protection against solid foreign bodies such as dust. Pretty much, protection from solid objects such as tools, insects, or dust, okay? The second number or digit relates to its protection from water and moisture. Like I said previously, the higher the number, the more the protection it has. So pretty much Zone 0 has a recommended IP rating of 67, Zone 1 IP 65, Zone 2 IP 44, and Zone 3 no IP rating is required. With respect to the 17th edition, or more recently the 18th edition, of the IEE and IET British Standard 7671 wiring regulations. And so, for example, if we were to fit the electrical fitting directly above the wash basin or the soap dispenser, it will be good practice to consider the area around the wash basin within a 60 centimeter radius of any tap. It will pretty much fall within Zone 2, where the Ingress Protection 44 is required. And the second number of digit of Ingress 44 denotes protection against water sprayed from all directions and limited ingress permitted, okay? So we are pretty much installing the soap dispenser in Zone 2 because it's got two taps and we are measuring a 60 centimeter radius. If it were an electrical equipment, if it was just one single tap, it would fall within the radius of that one single tap, the 60 cm, okay? And if it were outside of the 60 centimeter radius of either of them double taps, then, the soap dispenser would have been, installed in Zone 3. So basically, I'm not really worried about ingress protection because this is a liquid soap dispenser. If it were an electrical fitting, I would be worried about, ingress protection. So, what should you be worried about when drilling through a bathroom wall? First, you must understand that every wall is different. Studs usually are about 16 to 24 inches apart center to center. Anything between studs could be a pipe or a wire. Studs will run vertically the height of the wall, whereas pipes, wires, or conduit can change direction or branch off. Studs conventionally should be anywhere between 1.5 inches to 2 inches. Anything narrower could be a pipe or a wire. So if it's less than 1.5 inches, you should be wary, okay? And that's because the depth of a roughly cut stud is 2 inches and the smoothed out stud is about 1.5 inches. So let's think about what we're doing. If we've shown previously that, vent and drain pipes could be anywhere between 1.5 inches to 2 inches to 3 and 4 inches. And we've also got stud here that could be anywhere between 1.5 inches and 2 inches. And we've also got cold or hot water pipes, copper or metal pipes, as well as timber stud walls that are over 5 inches. Then it is absolutely imperative that you have stud finders or pipe and cable detectors so that you avoid, drilling through a water pipe or a metal pipe or a conduit pipe that's got wiring. Suffice to say, every wall is different. And so I will recommend that if you're going to work on any wall, that you properly map out the wall, which means plotting several studs at multiple heights, even if you're looking for only one stud. Because you would want to make sure that the stud that you do find is actually a stud, okay? So the Franklin's, yellow stud finder that I'd be using is pretty much a rough guide. It is a density detector and will locate any dense item behind the wall, not just the stud alone, okay? This invariably means that it could also pick up on pipes, wires, conduit, plaster keys in lath and plaster walls. It could also pick up on structural features like, your double and triple studs, and the rare diagonal support beams. And I would recommend that you place two or more stripes of masking or painter's tape at different heights on your wall and mark all objects on the tape rather than on your wall. That way you don't have to scrub off, pencil marks or pen marks from your wall. And remember, studs run straight up and down, and pipes wires frequently change direction. But like I said, just get a pipe, cable, or stud finder detector to be 100% sure. Although metal or nailing plates are usually installed to protect pipes. And why is it important? Just imagine if a trim carpenter who installs a baseboard shoots a finished nail right into the center of a cold water pipe in your bathroom on the other side of the wall. Say about 6 months' time, you might come to find your living room or your bathroom flooded. And that's because the nail that you've driven through in about 6 months would start to rust away enough for the leak to start. Initially, you might not have any flooding because the nail that you had driven into the pipe, was blocking the leak. Okay, so I've gone to great lengths to try to make you take cognizance of the layout of your bathroom and the respective zones in accordance with the wiring regulations. Okay, so I've been installing this soap dispenser. Firstly, pretty much utilizing the Franklin Pro Sensor 710 professional stud finder, pretty much to locate the position of timber studs, and then subsequently using a pipe and cable detector to ensure that all areas are free of hidden pipes and cables. So what am I trying to say? The stud finder alone should not be relied on exclusively to locate objects behind the scanned surface. Use other sources of information like your construction plans, visible points of entry of pipes, location of switches and outlets, you know, and the 16-inch and 24 inches stud spacing practices, which I have mapped out, on the wall here with two yellow 3M tapes. My expectation is that if we've got a 2x4 stud in the wall, its thickness should measure about 1.5 inches. Pretty much a 2x4 lumber that's roughly cut actually measures 1.5 inches thick and 3.5 inches wide. And when it is milled from a rough to a smooth surface, it loses approximately a quarter inch from all of its four sides. Suffice to say, the thickness and the width are each reduced by approximately half inch. So behind the wall, you may have wooden studs or pipes that are about 1.5 inches. The stud finder detects any inconsistency without identifying the nature of that inconsistency. So the three LED red light that lights up when you move the stud finder indicates that we might have a 1.5 inch stud there, because when you measure the three LED red points, it measures up to 1.5 inches. So you can see that we might have another stud there, but there's no way of telling if it's a wooden stud or a metal pipe. Okay, that's why we also need a pipe and cable or metal detector, as the illuminated LEDs or light emitting diodes, which are the red lights that turn on, may indicate the location of many different features, including but not limited to studs, beams, water pipes, gas pipes, wires, and inconsistency in the surface material or paint. So I've pretty much run the stud finder horizontally to locate, possible stud locations or the depth of the stud. So I'd also run it, vertically, to see how far up and down the stud beam runs across. Okay, to get accurate readings, just make sure that you press this button here, the yellow button here, before you place the stud finder on the wall, and also make sure that the stud finder itself is clean and dry, as well as the paint and wallpaper, before scanning for studs. So how do we know that the three illuminated LED red lights equates or equals 1.5 inches? We can only know that by measuring. So I'll get the Franklin sensor, up and close tight and measure, and you can see that it's about 1.5 inches. So anywhere pretty much between 3 centimeter and or 1.5 inches. Sometimes, you can get combined studs that measure above 1.5 inches. Or you might have foil backed insulation, although foil Backed insulation is not very common. Metal foil can cause inconsistent readings with all electronic stud finders, including this Franklin's sensor. Just be wary if you're getting, a lot of LEDs illuminating. It could be anything, from foil to combined studs. Just a personal opinion. I'd rather stick with the 1.5 inch stud if all I'm using is a stud finder. But if I've got a metal detector or pipe and cable detector, it will narrow down, what I've found, the feature, if it's a metal pipe, or stud or wooden stud, okay? Because pretty much this Franklin's sensor or stud finder does not identify what type of object it detects. And so you can see here, a lot of the LEDs are lighting up. It could be foil, it could be studs that measure up to about, 5 inches. It could be vent pipes, it could be anything. It could be electrical cables. There's no way of telling with the Franklin sensor. And that's what you need to get, like, a pipe and cable detector. Irregularities in plaster thickness and variations in construction materials can make it difficult to locate studs behind lath, and plaster walls. And if the plaster has mesh reinforcement, the stud finder may not be able to detect through the metal mesh, okay? As with any painting or drilling job, you are as good as your preparation. And why have we gone to great lengths, to try to understand the features behind the wall? And that's because we don't want to go brazenly or foolhardy drilling through the wall without, sort of like having a good grasp of, what's behind the wall. The last thing you would want is bursting a water pipe through your wall, because you could incur costly repairs. So you can definitely see on the other side of the wall in the bathroom, it's definitely picking up studs. When I move it in the horizontal position, it's picking up studs that are equally spaced, at about 16 inches apart. And when I move it vertically, the stud in the wall runs all the way from up to down. So I've got no qualms that I've got wooden studs in the bathroom on the other side of the wall. Okay. So at this stage, I'm somewhat confident that on the other side of the wall, I've got, studs. The next step would be to measure to see if they're equally spaced apart, between 16 and 24 inches. So I will take, the measurements from two locations. So the first one, I'll take the measurements. That's measuring about 24 inches, as you can see. And I'll take a measurement of the second one, and you'd see that, they're pretty much spaced at about 16 inches apart. So I'm pretty confident that on this side of the wall, I've got studs hanging out here. As you can see, having a good grasp of where the studs were enabled canvases to be hung up on the wall. And as you can see, this is about 16 inches. So I've pretty much worked out where the studs are on the opposite side of the wall and also on the other side of the wall. So I can put my dispenser anywhere I want to, but I'm choosing to put it on the green side of the wall, okay, as opposed to the grey side. I generally wouldn't install a dispenser at the corner of the bathroom. It's not a permitted zone. It's actually a cable route. As a general rule, you shouldn't install, 150 mil from the top of the wall, and at each side of a corner. Okay. What am I trying to say here? Identifying the location where you want to install the dispenser is really important. And also working out if the wooden studs align with the fixture. In this case, the fixture is the dispenser, which I will like to install just beside the wash basin. There is one stored just by the wash basin, but I do not have two studs that are equally spaced, to accommodate, the fixture holes. I would pretty much, just measure about, 40 to 42 cm from the floor. Like I said previously, all walls are different, and although, as a general rule of thumb, studs are spaced, 16 to 24 inches apart, sometimes you can have three or four studs within the 16 inches when doing bathrooms, high traffic corners, in bathrooms for showers, you know. And just to be sure that you're not hitting a PVC pipe, use a multi pipe and cable detector, metal detector, okay? And so the Trivo Bosch multi-level pipe and cable detector detects pipes and cables. All you need to do is push the simple one button control here. So basically, when the signal LED turns green, no object is detected. When it turns yellow, a metal object is in the vicinity of the sensor, it could mean two other things when it turns yellow. It could mean that the sensor is impaired due to the unfavorable wall material, or that a small or low-lying metal object is within the sensor area. But if the signal LED turns red and has a continuous tone, it means that a metal object is detected within the sensor area. But if the red is flashing very fast and with an intermittent sound, it means that there is a live wire or conductor that has been detected. So as I move closer to the radiator or picture, I would expect a red and continuous tone. But as I move further right, I would expect a flashing red signal. And if I trace the line of travel or the path, it could be that there's a wiring that comes from the extractor or from the lighting. So the wires may be coming all the way down, okay? As I bring it down through the pictures, it turns from yellow to green and then to red, which shows that, I've got a metal object down there. And as I take it to the corner of the wall, it flashes red, which shows that there's the live wire, that's been run through there. Pretty much you're not expected to drill 150 mil, from the edge of the wall in any instance, so it's not a favourable place for me to drill through, as electricians are allowed to run wires 150 mil from the edge of the wall, okay? So if you notice, as you approach a metallic object, it turns from green to yellow, then to red, and if it's a live wire, the red LED starts flashing. And so you can see between the pictures, it's flashing now. And if I run it through the corners, 150 mil from the edge of the corners, it flashes red. So I'm pretty sure that I've got live wires, running through there. So basically, for detecting metal objects, you must position the measuring tool against the surface being detected and move it sideways, okay? As a rule of thumb, if no metal object is visible in the base material, then the signal LED2 continues to illuminate green and no signal tone is produced or sound. But when the measuring tool comes closer to a metal object, the signal LED first lights up yellow and changes to red the closer it comes to the metal object. Do note that as soon as the signal LED lights up red, a signal tone is emitted, the pitch of which rises the closer it comes to the metal object. So pretty much over a metal object, the signal LED illuminates red and a signal tone is emitted at maximum pitch. And how about testing the detector, with fixtures that are not buried in the wall? So I'll bring it close to the tap and you can see that, the sensor illuminates red. I'll also take it to the casing for the multi-level detector and you can see that, it flashes red, a continuous red, which means that, a metal object is in close proximity. And the next step would be to take it to a wall that I know has got like ferrous and non-ferrous metals, copper conductors, gas pipes and whatnot, The multi-level detector is capable of scanning, it has a maximum scanning depth of 70 millimeters for ferrous metals and 60 mil for non-ferrous metals and 50 mil for copper conductors. And so on the other side of the wall, I've got, copper pipes, I've got wiring on the other side. So when I scan, the wall on the other side, I should expect, the LED to flash red. So as I move the detector on the other side, it flashes red, okay? So that shows me that I've got copper or metal pipes there. And if I move the detector by the corner of the wall or past the thermostatic regulator, it flashes fast red, which means that I've got live wiring or AC voltage running through, and a continuous tone, with a flash of red, could mean that I've got, a metal case and protecting, certain wiring and bits and pieces behind the wall. So you kind of get the idea. Just avoid places where you've got live wiring or metal or copper pipes, okay? And after due diligence, you can begin to install the dispenser. So now that I have selected the location where I want to install the soap dispenser device, I will place a bracket on the wall and mark the location of the holes for the screws with a pen. And then subsequently, after the holes of the screws are marked, I will remove the bracket, drill the holes in the marked area on the surface with the drill. So here I've got a 6mm plug, so I'm drilling a 5.5mm hole with a 5.5mm drill bit. The next step would be to place the pins or the 6mm plugs in the drilled holes, all them 3 holes. So push fit the plugs with the aid of a hammer and make sure that they're flush against the wall. The next step would be to install the bracket and connect the holes with the plugs or the pins, and then subsequently secure the screws with a screwdriver. So here I'd pretty much, torque the screws into the plugs with my hands, sort of like, using them as a sleeve before I screw them down. You can use a spirit level to see if it's, pretty much straight, but I think it's too late at this point anyway. So I'll get the drill, or you can use a screwdriver if you want. I'll just torque tighten, the screws into them plugs. So I'd pretty much just torque the rest of them holes. So the next step would be to replace the cover on the bracket back into the bracket until I hear the sound of a click. The next step would be to take out the soap tank device, then install the Fulcrum into the hole in the wall bracket cover, and then subsequently immediately place the device down until I hear a click sound. And to secure the bracket perfectly, I will place the key in the hexagonal hole in the bottom part of the bracket cover, and then repeat the same process for the other soap tank device. And just as before, install the Fulcrum into the hole in the wall bracket cover, and then subsequently secure or tighten with the key in the hexagonal hole. And finally, the last bit would be to put the key into the round hole on the lead and rotate to the right to open the device's lead. And pretty much to prevent spilling, fill 3/4 of the container with liquid soap, close the lid, and turn the key into the round hole to the left. And that's about it really. Don't forget to subscribe, like and share, helps the channel grow, and hopefully catch up with you later. Goodbye.